Okay, so the law of cosines. First of all, let's review the law of sines. We have angle, angle, side, angle, and side, angle, where we can use the law of sines for, right? Angle, or excuse me, side, angle is the one case that is special, the ambiguous case, where we could have no solution, we could have one, or we could have two solutions, okay? Now, what I want you to think about when we do have that ambiguous case, what is the range of inverse sine? You're thinking of the range of sine. I want the range of inverse sine. Now, there's two quadrants.
Negative infinity, negative 1, 1 infinity.
That would be the range of cosecant. Inverse sine is the one that only two quadrants work for.
0 to pi.
That is the range of inverse cosine. We're getting there? Negative pi over 2 to pi over 2. Do you remember that? When we were like, only from the second and fourth quadrant, and cosine can only come from the second and first and second quadrant. Okay? Well, since the inverse cosine only gives you an acute angle, that's why we have that ambiguous case where we have to do the supplementary, because inverse sine will never give us an obtuse angle, okay? And is it possible to have obtuse angles in triangles? Yes, it is, okay? So that's the trouble with the ambiguous case. When we find an angle using the law of sines, it's always going to give us an acute angle, okay? And so with that side angle case, we have to take into account it could be obtuse. And so then we have those two triangles, okay? Now, law of cosines we can use in two cases, okay? First of all, before we get too excited, we can use the law of cosines when we know side angle side or side. What? Side is what? Cool. Oh, I'm glad you think. Okay, the only combination we haven't worked with is angle, angle, angle. And remember, we talked about how that would be an infinite number of solutions, because we could have really small triangles with the same angles as really big triangles. Okay, so these are the two cases that we can use the law of cosines for. Go ahead and write down this formula right here. We have a squared equals b squared plus c squared minus 2bc cosine a. What I want you to notice is that we have our three sides represented. The loner side over here matches the angle right here. And the two sides that are being squared and added together on this side are the same as the sides that are being multiplied to the minus 2 cosine of whatever. Okay, so you can write down this one formula and know that we can adjust it for other pieces of information. Don't feel like you need to write both of these down. You can if you want to, but you can just rearrange things. Notice now how b squared is over here, which means we have angle b right here. And a squared is a side with c squared, and so 2ac is with the cosine b. Yes? Somebody who works very hard on a proof came up with these formulas. And it's possible. Like I have You know what we did on Thursday that went through how to get the law of sines formulas, that pink sheet? I do have something like that for law of cosines if you're interested. But basically somebody played around with factual information until they got this to work.
So like, do they use a percent or anything on that? So it looks like they did.
Potentially, I'm trying to see if there are any proofs. There is a proof of the law of cosines on page 460 if you need to reference it. Okay? But yes, it does look like they used the Pythagorean theorem to do it. Or the distance formula at least. Okay? Alright. So this is exciting, right? Now, I will say that the law of cosines, our formula is a little bit more intricate. However, it is very straightforward. We don't have any issues with the second triangle. We don't have any issues with no solution. It's just these formulas are going to work. And we know it. Okay? So we're going to do two examples. All right? Here is the first. I really want you to notice what the difference is between this picture and the pictures that we had yesterday for side-side angle. Do you notice how in this picture our angle is in between the two sides that we know? Okay? So it is important for you to recognize that we have side angle side, which means we get to use the law of cosines to solve this. You can try to use the law of sines, but you're not going to be able to get the right pairs of information to work. So you're going to automatically have to revert back to the law of cosines. Okay? So, law of cosines contains all three sides in its formula. What is the piece of information we're going to have to find first? We need that third side. Okay? So, here we go. A squared is b squared plus c squared minus 2bc cosine of A. All right, so in your calculators, make sure we're still in degree mode here. Good. Okay. We have 3 squared plus 10 squared minus 2 times 3 times 10 times cosine of 55. Put it in exactly as you see it. Okay, very good. This is what a squared equals, which means we need to do what with it? Square root, call up your last answer. And so side A is 8.64. How do we feel about that? What?
Find the other angles which you
Okay, so now some of you are getting excited. Can we use the law of sines to find the other angles? Is that possible? Well, let's think about this. Now that I know this side, do we technically have side-side angle available? Yes, we do. What I am going to do is we are going to do this entire problem using the law of cosines. And then in our next example, I will show you how it is possible to switch to the law of sines. And I'm going to show you how we're going to have to be careful when we do that because of that ambiguous case. Yes?
So is that going to be required that you're going to make a switch to law of cosines, or are we allowed to solve a triangle? Or are you going to make a switch to law of sines?
I'm going to let you choose because there is a little bit of risk for switching to law of sines. And I'll talk about that here in a little bit. Okay? So if you want to be more accurate with your numbers, remember I taught you yesterday, store alpha A for side A, and we're going to be able to bring up that number later if we need to. Okay? So let's come back up to our picture. Would you like to solve for angle C or angle B? C? Sure, why not? So if we're going to solve for angle C, that means we need side C all by itself on the other side. C squared equals A squared plus B squared minus 2 times B times A times the cosine of angle C. Here's the deal with the law of cosines. No matter what, you're going to get a straightforward approach. You're not going to have to think about any extra information. If you apply the formula correctly, you're going to get the right answer. But here's where some of you aren't going to like the law of cosines. Okay, we're going to have to do a little bit of algebra to get there. Now, we need to isolate the cosine of C. How are we going to do that? What's our first step?
Combine the first two terms that are the square root.
Okay, so we can combine these two terms and then do what with it? Subtract them over. Can I combine these two terms with this right here? No. Minus 2ac, ba, what is this? Minus 2ab cosine c, that's all together. So we need to add these two and subtract them over. All right? So this is what I'm going to do in my calculator. I'm going to take a squared, so I'm going to say alpha a squared plus 3 squared. This number right here is 83.585, blah, 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 blah. So what I'll do is I'll take 10 squared and subtract that number. Now, I'm going to keep it in my calculator, but I'm going to go ahead and write it as 16.41456, there, 4146. Okay, now what are we going to have to do? Now we're going to have to divide over this number to get cosine by itself. Okay, so I already have that 16.4 whatever in my calculator. I'm going to divide by the quantity, negative 2 times 3 times A. Okay, Now, if you want to use 8.64, that is fine, but I'm showing you a way to use your calculator to where you could be exact. Okay? So now that we have negative 0.316a equals the cosine of c, how do we get angle C? Inverse cosine. So angle C is 108.47 degrees. Okay. Make sure that in this step right here, when we're dividing over this product in front of cosine C, make sure you do so with parentheses, otherwise the order of operations in your calculator will not be correct. Okay? Now, this is where it gets nice, right? We have our second angle, so to find our third angle, we just have to use the rule of 180. We have one angle of 55, one angle of 108.47 degrees. What would our third angle be? Say that again. Okay. Are the biggest angles across from the biggest sides smallest across from the smallest? Okay. So our triangle makes sense. Okay. Let me ask you this. If we were to switch to the law of cosines, I'm actually very glad that you picked angle C. If we were to use the law of sines to find angle C, would the law of sines given us 108.47? It would not have. It would have given us 71 point whatever, okay? It would have given us a 71 degree angle, okay? And what would have happened is we would have looked at our triangle and we would have said, ooh, that doesn't make sense, okay? The problem with the law of sines is, the problem of switching to the law of sines is it's not going to find an obtuse angle for us, okay? What we would have to do is think about the ambiguous case, and if our triangle doesn't make sense, then we would have to pick the supplementary angle to use. Okay? Now, some of you are like, ooh, I don't really like having to think about that. Okay? And if that's the case, then you need to stick with the law of cosines the entire time. Okay? I will give you another hint here soon. But until then, if you wanted to use the law of sines after you found side A, which angle should you find first? B, because there would be no chance of it being obtuse. Okay. Let's go to this example. Okay, so first thing we need to notice is that we have side, 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 which means we can use the law of cosines. Okay, now finding an angle using the law of cosines is what requires a lot of algebra. With the thought of maybe we want to switch to the law of sines later, which would be the best angle to find using the law of cosines?
A.
Caroline? Everyone said A? Okay, someone tell me why A would be the best.
The most common. Because if one of them is going to be obtuse, it's gonna be A,
Okay,
so then you get that out of the way.
A has the biggest side, which means A is going to be the biggest angle. We don't know if it's obtuse or not, but it could be. And if we try to use the law of sines to find an obtuse angle, we have to deal with the ambiguous case. If we can find it with law of cosines, then we know the other two angles are fine to switch to the law of sines for. So let's find angle A, which means we need A squared equals B squared plus C squared minus 2 times A times C times cosine A. That is a 20. Please be careful with your algebra. Okay. What is, let's see, 34 squared is 1,156. We have 20 squared plus 18 squared is 724. And then 2 times 20 times 18, oh, that's not it. Let's try that again. It's 720. Okay, so let's talk again. What order do we do this? What's our first step? Subtract what? To where? The other side. So we have to subtract 724 to the other side to get 432. Then what do we do with that negative 720? Divide it over to the other side. Oh, I forgot that was negative. We made a wise choice. We have the cosine of A equals negative 0.6. Remember when we are looking for an angle, that's when we use the inverse function. So inverse cosine of negative 0.6. Angle A is 126.87 degrees. Okay. Since I know I'm going to have to use that angle again, I'm going to go ahead and store it in alpha A for angle A. That way I can use it later. Okay, so some of you may not like the law of cosines as much, especially when you are solving for an angle. So at this point, since we know angle A, technically, yes, we have a side, and then an angle, so we can switch to the law of sines. Okay? So if we want to now switch to the law of sines, we can. Let's go ahead and find angle B. So what we can do is we can set up the ratio that sine with an N. The sine of B over side B equals the sine of A over side A.
Why are we able to switch to that again?
Because now that we know A is 126.87 degrees, in our triangle we have side-side angle. So we can set up that ratio, or that proportion. Does that make sense? So what's nice about our calculator feature is now we can say the sine of angle A divided by 34, and then we can multiply that 20 over. So then we can take the inverse sine of that value to get 28.07 degrees. Okay. And once we have two angles, the third is like the best, right? All we have to do now is use our rule of 180 to determine angle C. When you take angle A and angle B away from 180, how many degrees are left over? Say it louder, Will.
25.
Do you agree with Will? You will never have two solutions with the law of cosines. Okay? However, if you switch to the law of sines and you are finding the biggest angle with the law of sines, you have to think about whether it should be the acute or the obtuse angle. If you want to avoid having to make that decision, avoid using the law of sines to find the biggest angle. Okay? So in this case, when we didn't know any of the angles, we started out finding the biggest angle. That way, when we switched to the law of sines, we would only have acute angles to find. You won't have a problem if you do that. In the case of side angle side, we would have wanted to avoid finding angle C with the law of sines. Okay? So we found the side using law of cosines, and then it would have been best if we were going to switch the law of sines to find angle B to do that, because it is the smaller of the two sides, and so we know it wouldn't be obtuse. Okay? If you don't want to have to think about all of that, stick with the law of cosines all the way through. Okay? So it's either a little bit more algebra or think a little bit more about the problem. All right. When we talked about the law of sines, I did teach you one shortcut for finding area. If we knew side angle side, we had 1/2 times the side times the side times the sine of the angle in between. I have a second area formula that involves all three sides. This is Huron's formula, and we use it when we know all three sides of a triangle. So first of all, you have to determine, okay, I don't know why they do this. Big S is what they use for area in our book. So if you want to just say area equals, that's fine. But here's the area formula where little s equals this. Huh? I'm sorry. Okay, so you have to find what S is first, add up all three sides, divide by 2, and then plug it into that formula above. Okay, so we are going to find the area of a triangle with sides of 43, 89, and 120. Go ahead and write those sides down. All right, so these are our three sides. First of all, we need to find little s, which we find by taking 1/2 times the sum of our three sides. What do we get? 126? Okay. So then our area is the square root of s times s minus side A times s minus side B times s minus side C. Here is my advice, and some of you are already like calculating away. Take a break and look up here, okay? You're going to have to punch this into your calculator anyway. So don't waste time trying to figure out what those three numbers are if you're going to put them in your calculator anyway. What would be the most efficient use of your time is to just put that square root in as it is. The square root of 126 times the quantity, 126 minus 43. Close the quantity times the quantity, 126 minus 89. Times 126 minus 120. Okay? Many of you will put 126 minus 43 in your calculator anyway. You might as well only do it once. So just put it in your calculator the way that you see it to get our area. Okay, that's an awfully big number, 1,523.7 square units. Does that make sense with the size of our triangle? We have very large sides, right? One of our sides is 120. Having an area that big is okay. All right. Okay, we have 10 minutes left in class. Much like yesterday, I want you to get your book out, and I want you to try at least one, if not two, of these log cosine problems. Let's see here. You start with number 5 and 8 and 11. Okay, so 5 and 8 are both side, 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 and 11 is side, angle, side. So if you get done with a side, 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 I want you to try a side, angle, side. All right? Make sure you are checking your answers to the odd problems to ensure that you are solving them correctly.